Okay, so in the last class, we discussed about how to declare dictionary, what are the different um, basic functionality, right? So we discussed about keys, values, and items, right? How to get the only keys, how to get only items, how to get keys and values together as items, right? So there are some more functions that we will do today. So there are functions, of course. Let's declare a dictionary. So I told you, like, dictionary can only be appended with a dictionary, right? So if I have to add something to it, only I can create a temp dictionary. Let's say I can create a temp dictionary, and okay, let's say I add 1:1:2:2, right? And now when I try to add to this, I can say dict one dot update, and then you add the temp dictionary. Okay, this is how you add the values, right? Now when you print dict1, okay, and when I of course run it, okay, so see dict1 is updated with these new values. Okay, now with this I want to give you an assignment. Okay, so same assignment which we did in list, right? So read marks for okay, so marks of 5 subjects for 5 students, and save the data along with students' names. Okay, along with student name. Okay, so this is the thing. So same thing that we did last time, but this time I also want you to put the name of the student along with the marks. Okay.
Okay.
Okay. So this is okay. So same thing, but you will also read name this time, and then you will not see the entire stuff. The mark stuff will be list only, right? But
Mhm.
the main outer list that we had created, that will be replaced with dictionary. So we will not put in the main list, we'll put it in a dictionary.
Okay.
Great. Now here also this is immutable, right? So I can change the value. Okay, I can say dict of 1. Okay. Okay. So now if I say dict of 1, what do you think I'll get?
1, 0.
Okay.
1.
Yeah.
Oh, okay.
See, so here we give dictionary, isn't it? Sorry, this
Mhm.
index. We give index
Yeah.
when you put a square bracket. So in this case, index is being played by keys, right? So index is being
Mhm.
played by the key. Keys plays the role of index here, isn't it?
Okay. Yeah.
So,
Yeah.
okay, so when you say dict of 1, it is taking it as key, okay? And I cannot say here 1, okay? If I do that, it will get error because it will then look for the index with 1,
Okay.
okay? And here definitely you can do dict 1 equal to 11,
2.
okay? So yeah, you can do anything. Values can be repeated, right? So it doesn't matter. And when I run it, you see 1 is replaced with 11.
Okay.
Okay, so you can do that. Now you also have here dict 1 or 2, we'll say dict 2 equal to dict 1, and we can say dict 3. Okay, so dict 3 dot copy. Okay, now when
Copy of DSCP2.
dict equal to your dict one dot copy, right? Now,
Okay.
yeah. So now when you print dict one, right? You see that all the three have same values, right? Then what is difference
Yeah.
between them?
That one is equal and one is copied.
Correct. So what is the difference?
Mm.
We did that in the list also.
Yeah, it was we did with the append function. So
See, we
so
append is to add, but
yeah.
we did equal to, we did list two equal to list one. We said list three equal to list one dot copy. So copy
Mm-hmm.
and equal to was there in list also. Append is to
Yeah.
add. So update, we used update to add.
Yeah.
Okay. So what do we do here? What is the difference here?
The difference here is that dictionary 3 is not equals to dictionary
All three
2.
are same, right? Now, what
Mm-hmm.
difference here is if I update anything to, if I make any changes to dictionary one, dictionary two will also be impacted. If I do
Mm-hmm.
update, if I delete, okay. So anything I do to dictionary one, dictionary two will also be updated. But dictionary three is like creating a copy and moving on. So dictionary one and two will point to each other. Okay.
Yeah.
Dictionary one and two will point to each other. So when you run it here, okay. So you see, dictionary one, we added three. So dictionary one got three. But we didn't add anything. We didn't do anything to dictionary two. Even then, dictionary two got a new value.
Yeah.
Dictionary one and dictionary two, they are same, just that they have different names. They are pointing to same data. So whatever you do with dictionary one, you will get reflected in dictionary two. Whatever you do with dictionary two will get reflected in dictionary one. Okay.
Yeah.
Dictionary three, the moment you create a copy, it takes the copy, it creates a separate copy. Okay, so it's like a Xerox copy. Okay, copy is like photocopy. So when you take a photocopy, at that very moment, two documents will be exactly same, right? Then
Yeah.
otherwise, after this, after photocopy, you make changes to the original one or to the duplicate one, each other will they'll become a separate copy then, right? If I make changes to the original one, then of course the copy will not have those changes, right?
Mm-hmm.
But when you say equal to, it's like I'm giving two names to same. So if say this document is called A and this document is called B, so if you make any changes to A, of course B will also have it because B and A are pointing to the same data. So
Yeah.
equal to is like creating a, so we call this as deep copy and this is a shallow copy. Same thing we did in the list as well. Okay. So yes. Now, how do you remove an item? Okay, you can do pop item. Now, DICT, say three dot, I do pop item. Now you see pop item does not have any value. Pop
Mm-hmm.
item does not have any value to give, right? There's no index, there is no value to give, right?
Yeah.
So, okay, so pop item will remove the value. It removes the value, okay? Which value it will remove? We are not giving index, we are not giving, what you call value or key. It removes the last updated value, last added value. Okay, so up until we are working with Python 2.10 or is it 11? Let me check. We're working with Python. I think it is Python 2.10. So up until 3.10, not 2. We are working with
Yeah.
3.10. Up until 3.6, okay, dictionary it used to remove randomly. Any value would get removed.
Mhm.
Okay. But now what they have made it is that only the last updated value. So in this case, which is the last? I'm talking about dictionary 3. So dictionary 3, what is the last updated value? 2. Okay. So when we
Yeah.
run this, okay, we will not see 2 here. Okay. So last updated value. Now let's see here. Dictionary 2 you have, right? And so dictionary 2 has 1 and 2, right? So last updated is 2, right? So 2 is gone. So that's what pop item does. Pop item will remove any one value. So you have to remove some value. You have to say, okay, pop item. But if I want to remove a specific value, okay, I want to remove a specific value. Okay, that's when you have what is called as just pop. So if I say dict2 dot pop, you see, pop needs key, not the value. Pop needs key. So in dict2, if I remove 2, okay, now when you print, okay, dict1 equal to dict1, so you see 2 is gone. Okay, so pop will remove the value. Okay, so this is how pop works. The pop item will remove any value from the dictionary. Pop will remove only the given key that we give. Okay,
Okay.
and the last one is your pop clear. So of course, sorry, not pop clear, just the clear. So if I say dict2 dot clear, entire data will be removed. Okay, so this will remove the data, but the dictionary will be there. It will not remove the dictionary. Dictionary will be there, just the content will be removed.
Okay.
Okay, so this is how we use dictionary. Okay,
Okay.
so dictionary is used to have values with given key. Okay, so in list and tuple, we never had to worry about key because the data itself will add the key. The Python itself will add the key, which is 0, 1, 2, 3, 4. That's why we call them as ordered collection. Okay, the first value is 0, second is 1, so on. But here, this is, here, there's no automatic, um, there's no automatic, order. We have to give our own set of keys.
Okay.
All right.
Yeah.
Okay, so with that, we finish dictionary. Next topic that we're going to talk about is called set.
Okay.
So let's do sets as well. Now, set is very similar to your mathematical sets. You would have done sets in mathematics, right? It's very
Yeah. Yeah.
similar to your sets in mathematics. Okay, so what is a set basically? Set is a collection of data. Set is just a collection of data. Now, it does not have any order. It does not. So if I tell you, for example, I'll tell you, name 5 fruits. Okay, if I tell you
Mhm.
name 5 fruits. So if you tell me apple, 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 apple 5 times, does it mean that, I should give you full marks for it? No,
No.
right? Because when I say name 5 fruits, I'm expecting you to name me 5 different fruits, isn't it?
Yeah.
And okay, and it doesn't matter which order you give me, right? You can give me orange first, apple later. There's no specific order that I would expect. So such
Mhm.
kind of answers are stored in set. So two properties of sets, very similar to list and tuple, but two specific properties which sets it apart from your tuples and list. One, there is no order concept here. It's unordered collection. So you cannot say which is first, which is second, right? Because see, if I tell you name 2 fruits, you tell me apple and orange. I say no,
Mhm.
wrong. It is orange and apple, not apple and orange. Doesn't
Yeah.
make any sense, isn't it? So the
Yeah.
order doesn't matter when you talk about sets. Set is only to represent the values. Okay, set is to represent the value. If I tell you name 5 cities, so you're representing 5 cities in the set. Okay, so
Okay.
those are only for values. So order doesn't matter, and number of times that you need, repetition is not allowed, right? So
Okay.
everything is saved as only one time. So how do we
Mm-hmm.
create set? Okay, so see, dictionary becomes key and value pair, right? But sets are similar to list and tuple. So list and tuple uses square bracket and simple bracket. Here we use curly bracket, just like dictionary. So if I say set one equal to this, and now if I try to do the type, what do you think the type of this would be? We did this yesterday. Type of
Yeah.
this will be dictionary only. Okay.
Okay. Yeah.
This is
Yeah.
dictionary only, right? But when
Mm-hmm.
we add only one value, okay, when we add, let's say, only 5. Now, if you do the type, okay, it knows, oh, okay, so there's no colon here. So no colon means it has to be set. Okay.
Okay.
So if you add only single value, okay, or values, right? Of course, I can add 5 comma 6 comma 7, right? So you are saying that, okay, it is set. So that's what Python knows. Because if you declare an empty set, okay, Python will not know the set or dictionary. And doesn't matter, right? Only when you add values, only things will matter. So when you add
Yeah.
just the value, no key, it knows it is set. If you add something colon something, then it knows, okay, the dictionary and some first something is key, second something is value. So
Yeah.
here, if I go and add, so let's say I told you name 5 even numbers. I tell you name 5 even numbers. So you tell me 2, 4, 6, 2, 4. So I want to know
Mm-hmm.
how many even numbers you have told me.
3.
And when you go and see length of set 2, you see 3, right? Because 2 and 4 you have repeated. I shouldn't give you marks for repeating, right?
Mm-hmm.
So that's what. And when you print set, okay. Now, if you print it, you see, we gave 246, you got 246. Now, again, if you run it, 246. Now, okay. But what I was trying to show you here is that you should not believe the order because it is unordered collection. So you don't know it is 246. Okay. Sometimes
Mm-hmm.
the values can change also. If I remove 24, then let's try to see. Okay, so it's giving 246 only. But again, I just said you cannot believe the order in which these values appear because there's no order in itself. Okay, whether
Yeah.
246, 642, 462, 426, all are same, all means the same. Okay, okay.
Mm-hmm.
So this is about set. Okay, you can also convert set to, so okay, so set is what? Unordered linear collection. Okay, so unordered linear collection. Now you can convert set to list, list to set, set to tuple, tuple to list. All these things are possible. List to tuple, all these things are possible. So if I declare a list, let's say I have a list. How do you declare a list? Square
List
bracket.
or yeah, square
So if I add the 10, 10, 10, 20, 20, 30, okay? Let's say this is the list. Now I tell you, remove the duplicate values. If I ask you to remove the duplicate values, so the easiest way to do is you say list one equal to convert this into set. Okay. So when I say
bracket.
set of list one, okay, the list one has become set. Now, because list one is list, I have to convert it back into list. I'll convert back to list. So first you
Mm-hmm.
convert into set, then you convert into list. And now when you print this list, okay, you will see that duplicate is gone, because when we convert it into set, it removes the duplicates.
Mm-hmm.
Then convert it back into the list. Okay. So two things have to keep in mind: duplicate value not allowed. Second, order you cannot trust. You cannot trust the order of list. Okay.
Okay.
Now here, if you want to add some element to a set, okay. So so if I add, let's say set two is 246, right? Let me add 8 to it. So set two dot add. So you see, the moment you say
Mm-hmm.
set two dot, you see these are the functions, okay, that are available, methods, right? Not actually function, methods. So you have update. Update is to add another set to it, okay. Update is to add another set to it, okay. What does okay, so we'll talk about it. So see, when I said dictionary 1 dot update dictionary 2, okay, if you see here, right, I said dictionary 1 dot update, okay, and this I gave a new dictionary, right? Let's call it a temp dictionary. Here also I did, right? Temp dictionary or something, right? So what did I mean? It means you're saying dictionary 1 equal to dictionary 1 plus temp dictionary. Okay, that means you add temp to dictionary 1 and update in the dictionary 1 only. So update will always update the existing, whether it is dictionary or set. So if I say here set dot update, okay, and here I give, what do I have to give? I have to give another set only. So this time let me add some different numbers. Okay. Now when you print set 2, you see 1614 got added. Now you see, where did 1614 got added?
Well, it's set two.
Set 2. But do you see any order?
No.
No. Right? 16 got added first, 4 got added second, last. There is no order in it. That's why I said, do not believe the order that you see in set. It is unordered. There is no order. It doesn't matter. Okay. If you need to handle order, then you have to convert into list or tuple. Otherwise, you cannot handle the order in which the sets are used. Okay. So update is used to add a new set to the existing set. Okay, so when you say set 2 dot update, the new set values got added to the existing set, which is set 2. Add we didn't do, right? So add is to add number. So if I say set 2 dot add, then I will add element 5. So you see here you can only add, let me make it 50. Here you can only add specific value, single value at a time. Okay. So of course, if you say after add, okay, you get set 2. Okay. And 50 got added. Okay. You also have copy. So copy also just works exactly like, you have equal to, and copy works exactly like list and tuple. Okay. So so list is also what is called as mutable.
This?
Sorry.
Yeah.
That is also called as mutable, unordered, mutable, linear, mutable collection. Wherever you are, doesn't matter. Okay, that means you can change the value of a list. The moment you can do update, see, update and add will not be there if it is not mutable. So there is a version of set which is called as frozen set. Okay, so frozen set is a version of set which is mutable, but we will not discuss that for now. We'll focus on a set only. So it is mutable. You can do update. You can do add. Okay, if it was immutable, then you cannot add to it. You cannot update it. Okay.
Mm-hmm.
So this is how your equal to and copy works. Okay. So these are the basic properties of set. Then the important properties. Okay, when you talk about set theory, okay, we have properties like union, intersection. What else?
Mm.
minus subset, superset. Okay, what does this mean? What are these, mean? So,
Union means combining two sets.
correct,
Intersection means picking out the similar elements in the two sets.
common elements, yeah,
Yeah, and minus would be subtracting the elements in each set.
correct,
Subset would be what which uh, set within the set,
correct,
and yeah, subset to subsets. So that's it. A superset would be
reverse,
I don't remember. Yeah.
reverse. So, for example, if you can see my paint, no, right? Okay, I have to share it, I guess. Okay, so I just drew this. So if the inner set is your A and your
Mm-hmm.
outer set is B, okay, then B is superset and A is subset.
Mm-hmm.
Okay, A is superset, B is subset. Okay.
Okay.
Now, yeah. So we'll talk. So yeah, you're right about update union and intersection. Let's talk about minus. Okay, so we'll just repeat what you just said in minus. Now let's say if this is your set A. Okay, this is your
Mm-hmm.
set. Uh, let's say this is your set A, and this is your set B. So this is
Mm-hmm.
set A and this is set B. Okay,
Mm-hmm.
then if I say A minus B, okay, I say A minus B. So I'm saying from A, take away B. Okay, so
Yeah.
let's see this. I'm saying I have 5 pens. Okay, I have
Mm-hmm.
5 pens. You take away sketch pens from me.
Mm-hmm.
Is it possible?
Yeah.
No, it's not
Wait.
possible.
No. 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 No.
I
No.
don't have sketch pens. You can't take away sketch pens from me, right? You can
Yeah.
only take away what I have, right?
Right.
If I have pens, you can only take away pens from me. If I have sketch pens, then so here, if this is A, right? And I'm saying take
Mm-hmm.
away B. Now, this part of B is not in A. So you can't take away. This part of B is in A. So you can only take away this part. Okay. So if
Okay. Yeah.
A minus B, you will get this part. This is your A minus B. Because
Okay.
the common part is taken away,
Yeah.
right? Similarly,
Similar.
yeah,
Mm-hmm.
go ahead.
Like intersection. That's it.
No, intersection is the common part, right? So
Yeah.
intersection is you're taking A minus intersection basically you're doing.
Okay.
You're doing A and removing intersection. Intersection is the common part.
Okay.
Intersection is the area which is common. So area which is common is this, right? This is
Mm-hmm.
intersection. This is A minus B. Now, if I do A B minus A, let's say this is your A and this is your B, let's say. Okay, so I call this, okay, this is your A. We will not change the order, right? This is left side is A, let's say right side is B. So if I say B minus A, B
Mm-hmm.
minus A, when you say B minus A, so this entire thing is B. From B, you're taking away A part. So this
Yeah.
extra part, you of course you cannot take away because it's not there with B. You can only take away this part which is there with the B. So this is what you get,
Okay.
right? And now if you talk about, of course, like union, right? Union is all together, right? So union is A, B, and common part appearing only once. Okay,
Mm-hmm.
it's your union. Okay. Now there's one more thing called as symmetric difference. Okay. Symmetric difference is, so if this is A and if this is your B, okay, symmetric difference is A minus B union B minus A. A minus
Mm-hmm.
B union B minus A. So A minus B is this part and B minus A is this part. So this part together you form. So this intersection part is gone away. Intersection part is not considered.
Okay.
Okay. So you have union, intersection, difference, minus or difference. Okay. And difference, symmetric difference. So these are
Yeah.
four important properties. And of course, you talk about superset, subset. So in this case, B is superset and A is subset,
Subset.
right? Then we also have something called as joint or disjoint. So if you take set A and if you take set B, okay, there is no common element between A and B. So we say these are disjoint, right?
Mm-hmm.
And all these, what we've seen so far here, all are joint. Joint means there's overlap. There's a common element between them.
Yeah.
Okay. So we'll see how to implement these in sets. So I'm going back to our Python program. And let's say I put A equal to 1, 3, 5, 7. And I put B equal to 2, 4, 6, 8. So A is 4 odd numbers, B is 4 even numbers. So obviously, there is no connection, there is no linkage, they are disjoint, right? So if I ask A dot is disjoint B? So what do you think the answer would be?
Uh,
True.
false. True.
They
Yes.
are disjoint. There's no
Yeah.
common between them. Now, if I
Yeah.
add 8 here, then of
Mm-hmm.
course it becomes false because
False.
one, there is one overlap between them.
Yeah.
Okay. So we'll take A and B like this. Now, we spoke about 4 functions, right? Union, intersection, difference, symmetric difference. Sorry.
Yeah.
So how do you do union? So union you can do, okay, using, so I can say print. Okay, let me print. And so looking at the comment, I will print them here. Oh, I need to drink water. Give me some.
Sure.
Okay. So union, okay, you can say A dot union B, okay, or you can say A, this pipe sign, okay, which is just above your enter keyboard, A pipe B, okay.
Okay.
Let's run it and see. So you see, so 1, 2, 3, 4, 5, 6, 7, 8. This is the union, all elements together. So you're putting them all together. But what did we say? Duplicates are not allowed. So 7 and 8, though they are repeating 2 times, we will get only one occurrence of 7 and 8. Okay.
Yeah.
Intersection, you can say A intersection B, or you can say, or print A and B. Okay.
Mm-hmm.
So now when I run it, so 7 and 8, these are only 2 values which are repeating common between them, right? So the intersection is 7 and 8. Difference, A minus B, B minus A. So A dot difference B. Okay, print B dot difference A. Okay, and this you can write as print A minus B. Here you will say B minus A.
Mm-hmm.
Okay. So now when you run it, you see difference of A minus B is from A, you are taking away B. So you only 7 and 8 is common. So 7, 8 is gone, 1, 3, 5, you get it. B minus A. So again, 7, 8 is common. So 2, 4, 6 remains. A symmetric difference, I mean, symmetric. Symmetric difference is union of A minus B and B minus A. So you should get 1, 2, 3, 4, 5, 6. Okay, everything except 7 and 8, the common part, right? So you say print, okay, A, this upward sign, okay, which is on your 6. Okay, so A, this, or you can say print A dot symmetric difference B. Okay, so these are your main functions of set. Now, if you see here, each of these functions that we discussed, each of the above methods, right? That's the right word, right? Methods we have seen, each of the methods returns a new set. So A and B, if you print, A and B remain same. That's why, we got all of these. So if you talk about A and B, okay, it remains same. There's no change in A and B. So each of these will return a new set. So I can say C equal to A union B, D equal to A intersection B, E equal to A minus B. I can say that. Okay. But let's say if you do not want to, if you don't want to create a new set and update the first set instead, then what you do, you say first set dot, okay, dash 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 update. So if you want to do union, you say union update. Intersection, you say intersection update. Difference, you say difference update. Symmetric difference, you say symmetric difference update. So what happens? This is like saying, first set equal to first set plus whatever, right? So you see here, if I say A dot, you have union, difference, symmetric difference. But if you come down here, you have symmetric difference update, intersection update, just update. So what is this? This is like exchanging the existing, okay, value. So if I say difference update B, so the new A value will be changed to the answer or the result of this. So A was our 1, 3, 5, 7, 8. But A minus B, 7, 8 is gone. So A is not changed. So if you want to change the set, then you use update. So it is update for union update, intersection for intersection update, and so on. If you do not want to change the value, don't use update. Okay, just use union, just use intersection. Okay, so these are the properties of set theory. So with that, we complete our collections topic. So we have seen strings, we have seen list, tuple, dictionary, and now sets.
Okay.